Okay, boys and girls, strap on your boots. Today is a difficult oxidation reduction reaction. You got water and the manganate ion plus sulfur 2 minus ion, manganate ions -1, of course, goes to form sulfur metal or sulfur solid. And as you know, all elements by themselves exhibit a zero charge, plus manganese sulfide plus hydroxide ions. Now, all these can be broken into what we call half reactions. The half reaction of the manganese is the MnO4 goes to form MnS, and that exhibits 10 electrons that are gained when you go from a charge of the manganese from a plus 7 on the left side to a plus 2 on the right side. That's 5 electrons times 2, because that's the multiplier between the manganese and the sulfur. So there's 10 electrons gained on the reactant side. And over here on the left, you have the multiplier is 5, because that's the number of electrons gained from the manganese going from a 7 plus to a 2 plus. So the sulfur goes from 2 plus, or 2 minus rather, to 0, and thus the gain is 2 electrons. So we have 10 electrons accounted for on either side with a half reaction method. Now with the inspection method, you take it a step further. You take your water molecule and break it into hydroxide and hydrogen ions. You got your manganate -1, your sulfur 2 minus, your manganese sulfide as a product, plus water plus hydroxide. We've forgotten the sulfur metal. We should put that in there. I don't add that in until the end with this inspection method, but probably be a good idea to realize that the sulfur metal zero charge is in here in both locations. I think it could easily be accommodated with a little bit of dexterity here. Okay, add the sulfur solid in for, normally you would just add it back in at the end down here. So you got 4 hydroxides, 4 hydrogen ions. This is enabling you to account for the hydroxides on the right side. You got sulfur 2 going to sulfur 0 here. Sulfur 2 minus there, sulfur 2 minus there doesn't change, so you don't account for it. 5 electrons times 2, 4 waters times 2, the manganate ion times 2, and the sulfur 2 minus times 2, and then you got on this side you got 5 sulfurs, and this probably should indicate that up here also. Let's 5 sulfurs up there, because that's the change. And the manganese sulfide and the 8 hydroxides. Now, let's drop that 5 out because that just confuses the situation. We get down to 8 waters. Obviously, if you multiply times 2, you get 8 waters. You got 2 MnO4 minus plus 5 because that's the change for the manganate. But that doesn't account for these 2 sulfurs here. So you have to have 7 sulfurs over here to account for the 5 sulfurs there and the 2 sulfurs here. And 2 times the manganate, 5 sulfurs is the normal, 16 hydroxides, which is accounted for with 8 oxygens. 8 times 2 is 16 hydrogens, where you say, wait a minute, you got 16 oxygens. 2 times 4 is your other 8. 8 plus 8 is 16 oxygens. 16 oxygens, 16 hydrogens, 16 hydrogens, you're balanced. And that's two different methods, the addition of the half reactions and the inspection method. This is, I won't say as difficult as it gets, but it's pretty difficult. So go through it step by step, see if it rationally comes through, and then I'll come through with a later method that I call the bracket method, and that I have a great deal of success. So there's 3 different methods for balancing oxidation reduction. All of them get the correct answer, but you want to find the one that you understand the best, because it can be used over and over again.